Hello and welcome to Quantum IAS. We are solving questions of day 11 of DAW January Mechanics and Waves and Optics. So let's get started with the first question. The first question is during an earthquake, a horizontal shelf moves vertically. If its motion can be regarded as SHM, calculate maximum value of amplitude of oscillation so that book resting on it stay in contact with it always. Right? G, we have to take this, and this is the time period of the oscillation. Right? Simple, straightforward question, right? That too from a basic 11th level question. So what should we write in the introduction? So in introduction, we can simply write about what do we mean by SHM, right? So SHM, you can write that simple harmonic motion means that the particle is oscillating in a linear fashion, right? They are following that F is equals to minus Kx. That is the restoring force that is acting on it. And it is linearly. The x to the power n, where n is equals to 1, right? No need to go in that detail. Something like that, right? So simple harmonic motion is regarded as oscillation of the linear term. Now what you need to write here, that x should be small, right? X should be small as compared to the oscillation that it can make, right? So this is what we need to keep in our mind. In the introduction, we have to write the definition of SHM. Okay. Now this is a straightforward numerical question, so we will write here a horizontal shelf moves vertically. So let's say this is the horizontal shelf, and this moves vertically. This will be moving vertically, right? So let's take this object which is kept on the shelf, or you can consider this as shelf, right? Because it will be on some ground, right? So let's say this is our ground and this is the shelf, let's say. Now what all forces are acting on it? So when it is resting on here, it will be normal reaction acting on it, and there will be the weight of it, that is the gravitational force acting on it, right? And whatever the motion, let's say it is trying to go in this motion, we can simply write that, let's take A, so n minus mg is equals to A, ma, let's say. So when it is oscillating, it is equal to this, right? Now in question, they are asking what is the maximum value of amplitude it can get. Now we know that if it is oscillating, acceleration will be in the format of minus omega square y. Let's say this direction to be y axis. This is the basic condition of the acceleration. From here, we can simply say that A will be what? Equals to minus k by m x, and this is what we know at omega square, right? So acceleration can be written as minus omega square y. One more thing. So we can write simply n minus mg is equals to minus m omega square y. Now, when let's say y tends to y maximum, when this is its maximum amplitude, right? So there will be the limiting case of the normal when it will tends to 0, right? There will be the limiting case. Limiting case of the normal reaction, right? It will just leave the surface, or tries to just leave the surface, right? So from here you can simply see that it becomes minus mg is equals to minus m omega square y maximum, m minus cancel out, and y max is equals to g by omega square. And in question, g is mentioned there. Omega, we know that it is equals to 2 pi by t, right? So it is 2 pi by t. When you put these values, t is given as 0.5, I guess. Yes, it is given as 0.5 second. It is 9.9. If you will find out, y maximum will be almost equal to 62.7 centimeter, right? So this is what we will get in the value. Now understand one thing. Here, one thing you need to write about it in the conclusion, that this is the maximum amplitude that it can sustain, right? If it is also, let's say, if we have two objects, right? One is resting on another, and this is going up and down, right? So there will be some frequency where the object, this one, can fall apart from this one. So this is the maximum displacement that it can suffer from this frequency. After this displacement, it will leave the ground, it will leave the surface. So these things you have to write in your conclusion. Also in the conclusion, you can mention, based on these things, we can measure what is the intensity of earthquake. So what happened, we can assume, there is an assumption that the buildings or the things that are occurring during the earthquake are basically doing the SHM, doing the simple harmonic oscillation. But this is not the case. We know that. So in reality, this is not the case. But as far as the assumption is concerned, this you can write. Okay. This was small question. Now, next question is, what is damped harmonic oscillation? Write the equation of motion and obtain their general solution of the oscillation. Okay. Discuss the cases of deadbeat, critical damping, and oscillatory motion based on the general solution. बहुत कुछ पूछा है इसमें. What would be logarithmic decrement of the damped vibrating system if it has amplitude of this, which reduced to 3 centimeter after 20 oscillation? Let's get started with this. So first of all, in the introduction section, we have to define what do we mean by damped oscillation. So whenever we study about damped oscillation, always remember that there must be a resistive medium. There must be a resistive medium. It can be air drag. It can be viscosity of the fluid, whatever. There should be a damped resistive medium. So how we define damped oscillation? So damped oscillation is a type of oscillation in which amplitude or the energy decreases with increase in time due to the presence of the resistive medium. Now understand, amplitude decreases that we are saying. We are not saying that amplitude is decreasing whether in a periodic fashion or aperiodic fashion. That we will see all the cases of the damped oscillation. But one thing is sure, that the amplitude will decrease, right? So this is what we need to write: amplitude decreases and the resistive medium. These two are the keywords that you should write in your definition part of the damped oscillation. Now, let us take a system. Always write, let's take a system, spring mass system, M, which is oscillating in the direction. Let's take this direction as X only, and it is oscillating in this direction. So when a small displacement is given to this mass, it will try to oscillate. And when it try to oscillate, there will be two forces. One of the spring forces acting by the spring, it will try to resist the motion and it will try to restore, right? Another force will be the resistive force, which will try to end the motion, right? So these four will be acting on it, and the net sum of these we can write simply that the net unbalancing force, because earlier the gravitational force will be balanced by the spring force, right? We know that इसमें mg लग रहा होगा नीचे, that will be balanced by the mean position, right? And when we do the oscillation, we do the oscillation from the stable equilibrium, from the mean position. All these things, I hope you know and understand. So we can simply write from here the equation that total acceleration m d square x upon dt square, just like write like that. This is the m into a mass into acceleration is equal to the total net restoring forces or the forces acting. So first forces acting is minus kx, right? When it is going x, it will have some velocity v. So there will be two forces, a restive forces which will try to oppose the velocity, and this x will be opposed by the restoring force. So another force that will be acting is equals to minus b dx by dt. So from here, if you put here, so it will become d square x upon dt square. I hope all of you know that, 2 gamma dx by dt plus omega naught square x is equals to 0. So this is the equation that we are talking about, where we have to write gamma is equals to b by 2m, right? And omega naught square is equals to k by m. And where omega naught square is what? The angular frequency of the oscillation when it was undisturbed, when it was undamped. Okay. So this is how we can write the equation. So try to understand the question. Every part you need to answer. First, define damped oscillation. So we will defining the damped oscillation. We will defining the resistive forces, right? All these things. After that, write the equation of motion. You have to write the equation of motion, and then the general solution for the oscillation. So we have defined the damped oscillation. You can define more. Here we have obtained when it is moving away from its mean position, right? Let's say this was its mean position and we have displaced it over x. Then this is the net restoring or the unbalanced force acting on it, right? And as it is moving downward, these forces are acting upward. That's why we have kept minus minus here, right? I guess hope. So now what we will do, let us assume that x is equals to some c alpha t, right? This we can assume that x is equals to some c alpha t. Then we can simply write dx by dt is c alpha e to the power alpha t, and then d square x by dt square is equals to c alpha square e to the alpha t. I hope all of you, when you are at this stage, when you are practicing question, I hope you know these basic derivation, right? If you put here, if you put these value in above equation, what you will get? You can simply get c e to the power alpha t common, and then you will get alpha square plus 2 alpha gamma plus omega naught square is equals to 0, right? Certainly this is not equals to 0. This is what the solution that we have wanted. This is equals to 0. So if you put this equals to 0, you will get alpha is equals to minus gamma plus minus root under gamma square minus omega naught square. Simple. Yeah. Quadratic equation. So from here, let us assume one more point. So let's take omega dash, or omega sometime we call, equals to omega naught square minus gamma square. So this will turn into iota. So if you put here, so x t, it will be c e to the power alpha t. What is alpha now? Alpha is this minus gamma plus minus root under gamma square minus omega naught square into t. This we can simply write that I omega dash. So simply the equation will become x is equals to x as a function of t, obviously. X as a function of t is equals to, let's write a, some constant, e to the power minus gamma t, and this will become e to the power plus minus I omega dash t. So this is the general equation that we are talking about. This is the general equation. Again, try to find out. 20 marks a question hai, this is 20 mark question, and they're asking so much of thing. So first thing defined, second equation of motion we have got, then general solution we have identified, right? So always write in these three to four lines, right? Then we will discuss the case of deadbeat, critical damping, and the oscillatory vibrating system. So let us start with the cases. Okay, before that, one more announcement that is to be made, that we are, I hope all of you know that we are uh, introducing our next foundation batch. Foundation batch 2.0, cohort 1 for CSE 24. Why 2.0? Because all the lectures will be new, and whatever the things that we have learned so far will be integrated here, right? So let me give some with it. And we are starting with the quantum mechanics. So based on the request from various students, that they have said that they have some difficulties in few modules, so they don't want to enroll in the complete program, but they have some doubt in quantum mechanics, some have doubt in solid state, some have doubt in thermodynamics, so they can do the module course now, right? So the module course starting from the 1st March, right? This is the exactly same course that we are going to teaching in the foundation batch, right? So it is just sub part of the foundation batch program. So what things we are doing here? First, the classes will be live and interactive, and I have planned around 20 classes of 2.5 to 3 hours each, right? And these classes will make ensure that you have a complete command over the quantum mechanics, because if you want to command paper number 2, you should have a complete understanding of the quantum mechanics with its foundation level, right? And who can attend? If you have a good knowledge of class 11th and 12th level, no need to study anything beyond that, right? Just read the NCERT of 11th and 12th, just have a brief understanding whatever you have studied in your 11th 12th. After that, everything will be taken by me. Okay, then we will be having daily practice paper, right? The daily practice paper will have all the PYQs that was asked in previous 20 to 25 years. Again, all the questions that are given in standard books that we do in the NGP also, right? Whatever. And also there will be a self-evaluation questions, right? So per day you will be writing 1 or 2 answer, and that will be evaluated by you only, right? And all these will be discussed in the class. Let's say in class number 1 you will get the DPP 1. So in class number 2 we will be having a discussion of these. Okay, now in this question we are going to have 100 plus question answer practice, that with proper intro and conclusion wala thing, with intro and conclusion, that the same way that we are doing right now. In the same way, what should be written in the intro, what should be given in the conclusion, how you should proceed the answer, that will be done. And 200 plus numerical we will be doing from the PYQ, also from the standard books, right? There will be 2 module test will be there here, and here you will get the discussion as well as the evaluation of your copies. Next, most important thing, handout and updated notes. So till now we have a handout for few topics of paper number 1, but this year I'm going to give a handout for every topic, right? So quantum mechanics, this is the complete new handout we are preparing from the scratch, and the notes are also updated. Okay, this is the all information regarding the quantum mechanics. It is starting from 1st of March and it is live, so you need to keep this in mind, right? For more information you can check, पता नहीं, description में you can check, also you can check from the YouTube. telegram also, right? Okay, end of this prachar. Let's get back to, this is the general solution that we have got. Now we need to see all the three cases. So we will be seeing these three cases in a very brief manner. Okay, so first one, deadbeat, case one. Overdamped. And understand, this will be not the oscillation when gamma is greater than omega naught. When gamma is greater than omega naught, you can simply see that omega dash, that is written under omega square minus gamma square, it will be not real. It will be some imaginary. If you put all these things, right, you will get the answer, that is x is equals to e to the power minus gamma t. And here we can write a1 e to the power I omega dash t plus a2 e to the power minus I omega dash t. So we are just bifurcating these equations here. Now, you can put the value of omega dash t, it's up to you. This is what we will do in the overdamped case, right? And always remember that this is not a periodic motion. This is not a periodic motion. This you need to understand, right? And this is also deadbeat motion. Deadbeat ही लिख देना ऊपर, because they have asked about the deadbeat motion. Okay, so here in this case what happened, the resistive force is much greater than the oscillation, right? So it will damped quickly. We can draw the graph here, but at the last we will draw the comparative graph, that will be more useful, right? Because it's a 20 marker question, we have to limit whatever the thing is there, right? Now case 2, critical damping. So for the critical damping, gamma is equals to omega naught, right? So the determinant will be equals to the 0, right? So x can be simply written as a1 e to the power minus gamma t plus a2 t e to the power minus gamma t, right? Again, you just need to write these solution. That's it, right? Just put the values. तुम्हें put करना होगा, one more line you need to write here, one more line you need to write here. Just putting these things in the condition. I'm just writing the final answer. Next one is the underdamped case, and this is the oscillation. This is what we known as damped oscillation, right? And here you can simply write that omega naught is greater than the gamma. And if you put here, the x will be equals to e to the power minus gamma t, a1 e to the power minus, sorry, not minus, I omega dash t plus a2 e to the power minus I omega dash t. And if you solve it further, right, e to the power I theta plus e to the power minus I theta, right, Euler form, it will be give you the sine theta. So it will become a some constant e to the power minus gamma t sine omega dash t plus 5 with some phase. So this will be a periodic motion. This will be a periodic motion. This will be your SHM, not SHM, sorry. This will be your oscillation. And the oscillation will be occurring in the amplitude, but it will decay with time, right? This will decay the oscillation. Always remember this thing. So if you make the graph, something look like this. This is the case 3. This is the case 1. And this is the case 2. So in critical damping, it will move, it will damped, or it will die faster, right? Also, one you need to find out the time period. Time period t is simply 2 pi by omega dash. This is the new time period, and omega dash we know that it is equals to omega naught square by gamma square. When omega naught is much greater than gamma, so you can ignore that, and t will be equals to 2 pi by omega naught. That is equals to the t naught earlier time period, right? So this statement you should write in your conclusion, this thing, right? Also, you can talk about the ballistic galvanometer here. One line you can talk about, right? Okay, now let us talk about the next part. And the next part is basically the initial amplitude by 30 centimeter, 3 after 20, right? We know the formula, we directly apply the formula. That is lambda is equals to 1 by number of oscillation ln a dash jo after upon, sorry, a naught by a dash. So we put it in the question, it is given, it's simple. This is ln 30 centimeter by 3, that is almost equals to 0.115. So this is the logarithmic decrement, how the amplitude are dying, right? You can understand this is only for the case 3 that we are writing here, right? So this is the how the amplitudes are dying. This is the logarithmic decrement. Okay. So that's all for the day. We will meet in the next video, and there we will be talking about the day number 12 of the waves and optics. We will try to upload more and more video as soon as possible. Thank you so much. Bye bye.